Hello class, and welcome to the week 9 recording for COMP-111. So as you can see, today we're going to talk about wrapper classes, sort algorithms, and multidimensional arrays. So it's not a huge lesson, but it is still a very important lesson to go over. All right, so wrapper classes. So you've probably noticed that when we're dealing with array lists, and it's not limited to just array lists, there are other constructs for which this is true as well, an object is required. So while we can store primitive data in the array data construct, we cannot store primitive data in an array list construct. And so wrapper classes, what they do is they provide us a way to take primitive data and to convert it to be a class so that we can use it in situations such as the array list. All right, so the whole purpose of the wrapper class is to convert primitive data into a class. And so, for example, an integer data, so this is your primitive data type, int integer, would become the integer with a capital I wrapper class. Remember, wrapper classes are classes, and the Java naming convention for classes is that they start with a capital letter. So again, for double with a lowercase d, which is our primitive data type, the wrapper class becomes double with a capital D. For character, where char is our primitive data type, character with a capital C is your corresponding wrapper class. And then Boolean with a lowercase b would be primitive, where Boolean with an uppercase b would be your wrapper class. All right, now the wrapper classes do have some methods associated with them. You can go out to the Java docs to see a full and exhaustive list of what those particular methods are, but a couple of them would be like parse integer, which converts string data into being a primitive data type or into an integer value. Compare allows you to compare two integer object values. Equals checks for the equality of two integer objects. So there are a lot of different wrapper class methods out there, and I encourage you to go to the Java docs just to take a look at what those might be. All right. So along with wrapper classes comes the concept of auto boxing and auto unboxing. Now remember, whenever you have a class, you have to call the constructor in order to create that class. And here's what that would look like. So let's say we had integer data value 10. So we have this numeric literal of a value of 10, and we want to convert this into the integer wrapper class to make it an object. So that would be call your data type integer with a capital I. This is your wrapper class. Give your variable some name. This is your object variable, and I just went with new int. Equals new, and then integer, which is the name of your constructor, which is always the same as the name of your class, right? So capital I integer, and then we give it the value 10. And so this would create a wrapper class object from the integer wrapper class containing a value of 10. All right. Now what Java said is they're like, okay, we know what you're doing, right? We don't really need you to go through all of this work to make this numeric literal 10 an object, an integer object, because we know what you're doing. So they provide what's called auto boxing. So it's automatically puts your literal into the box, right, into the object box. And so what you can actually do is just this integer. So again, this is your wrapper class data type, integer with a capital I, new int equals 10. And this is the same thing as calling the constructor. So you can certainly call the constructor to create your integer wrapper class object, or you can just use the shortcut, the auto boxing, and you can just say integer new int equals 10. Okay. For example, we can also have integer x equals 10. So our variable, this is primitive data, variable x equals 10. And we can call the constructor integer new int equals new integer x, right? With integer capital I, the data type, and the constructor always being the same, giving it our 10. And this will certainly create an object variable, an integer wrapper class object variable with a name of new int that contains a value of 10. Or we can use the auto box and say integer new int equals x, okay? And because x contains a value of 10, then our new integer wrapper class object new int will also contain the value 10, but now as an object, not as primitive data. Okay. So likewise, Java said, well, if we're going to let them auto-box it with this shortcut means to put it into the wrapper class, we might as well allow them to auto-unbox it and take it out of the primitive or out of the class and make it primitive data again without having to go through all the rigmarole. So without the auto unboxing, here's how that would look. So we've created our integer new int equals new integer sub 10. So we've created an integer wrapper class object called referred to by the variable name new int, contains a value of 10, and now we want to get it out, we want to make it primitive data, we would have to do int x equals new int dot int value and retrieve it. So we would actually have to call the method int value to retrieve that primitive data and put that into our variable of x, which is defined as primitive data integer here. So, but we can use the Java shortcut, the auto unboxing, and we can just say integer x equals new int, and it will automatically convert it from the integer class to the primitive data int and put it into our variable x. Okay. So that's it as far as auto boxing and auto unboxing. That works for all of the wrapper class objects, so it works for integer, double, character, and boolean. All of them have the auto box and the auto unbox feature. And remember, when you're dealing with something like array lists, and there are other constructs along those same lines that require an object, if your intent is to store primitive data in there, you're going to have to first put them into a wrapper class to make them an object, and then store that wrapper class object in the array list or whatever construct you're using. Okay, sort algorithms. So sort algorithms, these are kind of awesome. So I meant to bring this up ahead of time, and I apologize for not doing so. So let me go ahead and bring this up. So I'm just going to the course website, and anywhere in here is your reading guide. It's all, every week, there's the reading guide right here. If you click on it, then down here is the reading guide. And if we were to pull up the reading guide and go to the chapter 14, you see sorting and searching here. And I guess I'm just going to have to drag down to chapter 14. Hang on just a second. Where am I at? Getting close. So I apologize. I meant to have this up ahead of time. Okay. Not quite there. Almost, though. There we go. Sorting and searching. Okay, so this provides you with, so this one is actually kind of amazing, this reading guide here. This tells you about each of the different sort algorithms that were provided in the book. So we have the selection sort, and the whole intent of the selection sort is it divides the array into two, where everything that's already sorted is on the left half of the array, and everything that's unsorted is on the right half of the array. There's the insertion sort algorithm. It also divides everything into two as above, but it also tries to determine where to insert the next unsorted item. So it kind of takes your selection sort one step further. And then there's the bubble sort, which bubbles everything to the right into the correct position. So essentially you would say everything on the left is unsorted, where everything on the right is sorted with your bubble sort. Okay, so let's go over here and take a look at this reading guide. So here we have the selection sort, and it gives you a description of what the selection sort is. But then what it also does is it gives you the algorithm for the selection sort right here. Okay, so this would be as if you called a method passing it in your array that you want sorted, the leftmost position of the array. And what is our leftmost position of the array? Remember, that's always 0. It's your lower boundary. And then your rightmost position of the array, which is your upper boundary. So that's the length of the array minus 1, or it's going to be just the length of the array. All right. And then in here is the actual sorting algorithm. So from here to here is your sorting algorithm. And then once it's all done sorting, it just returns the array back. So that's what this method does. If you just wanted to do the sorting algorithm itself, you would just start with the 4 to right here. And this is actually the portion of the sorting algorithm. If we continue on down in this reading guide, it gives you a visual of how this looks. So we're assuming these are the values in your array. And remember, it's going to bubble things to the left that are not sorted and bubble things to the right that are sorted. So what it's doing is it's looking for the lowest value. So it's going to kind of go along here and go, is 3 less than 8? Okay, yeah, but that's still not my lowest. What about 6? What about, and it eventually finds 2 and it goes, oh, that's the lowest number. Let's put 2 in the first position, and it kind of switches the first position. So what was in the first position goes to where 2 was, and 2 goes into the first position. And then it comes to the next one and it checks them. Which one's the lowest now? Oh, well, that's 3 and that's already there. Okay, don't do anything. And then we come down here and we've got 2 and 3 and we've got 6, and we're like, all right, what's the lowest one now? Oh, that's 4. So let's flip 4 and 6. So now we have 2, 3, 4. Now we have 8, 6, and 7, and it's like, which is the lowest? 6 is the lowest. Let's flip what's 8 and 6. So we have 2, 3, 4, 6, and then we have 8 and 7, and then eventually we flip those two, and now we're sorted in a correct order. Okay. We have the insertion sort. And it's also going to divide the array into 2. And again, it's assuming that you're calling a method, but for the sorting algorithm itself, it goes from here to here. Okay. So you can actually just copy this code from here to here. It is expecting an array of data type integer. Leftmost boundary is 0, rightmost boundary there. And then here's how it works, is it looks and it goes, oh, 8 and 3, 3 is less, let's flip that. So now let's compare 8 and 6, 6 is less, flip that. Let's compare 8 and 2, 2 is less, let's flip that. Then let's compare 8 and 4, 4 is less, let's flip that, and so on. And it just works its way on down, flipping these items each pass through the array. Okay. And then we get down to the bubble sort, which is my favorite. Don't ask me why. Maybe having something with bubbles, I don't know, it has a more fun name than selection insertion sort. There are actually 3 iterations of the bubble sort algorithm provided. And again, it's got a method wrapped around it. But if you wanted just the logic for the bubble sort, you come inside here just before the return statement. It's expecting an array here, leftmost boundary of 0, rightmost boundary of the length of the array. Okay. Each version of the bubble sort, so we have bubble sort 1, bubble sort 2, and bubble sort 3, each one is slightly more efficient. So bubble sort 3 would be the most efficient of the 3, so it's a little bit longer in what it does. All right. And then here we show how it bubbles things up to the left. So it's going to look at 3 and 6 and flips those two, and it'll flip 8 and 2, and it'll flip 8 and 4, and it'll flip 7, and then after the first pass, 8 will be in the correct position, and then it's only going to work from 3 to 7, and then it'll flip these and go, oh, 6 is greater than 2, move that, 6 is greater than 4, move that, but 7 is right where it needs to be, and it'll lock that in place, and it just keeps going until eventually the array is sorted in the correct algorithm. Now, I would recommend, highly recommend, that if you're having issues understanding these, like you're reading through the different sorts, the insertion, the selection, and the bubble sort, and you're just not really understanding how they work, what I would recommend that you do is you come out to YouTube and you can type in insertion sort visualization. And so here we've got one with Romanian folk dancers, we've got animated, here's Hungarian folk dancers if you don't like the Romanian, we've got like a little algorithm. There's all sorts. Here's a bubble sort visualization down here. There are all sorts of different things. Here's insertion sort compared to bubble sort. So you got like bouncing balls. There are all sorts of visualizations out here on YouTube. So if for some reason you're having trouble comprehending or following what the selection sort, the insertion sort, or the bubble sort does, come out here and run one of these videos. Some are longer than others. but run a video so you can actually see the visualization of it, and that'll really help you out. Okay. So the big thing I wanted to let you know is that these algorithms are solid, and what I mean is they are correct. They work 100% as written when you're sorting an array of primitive integer data. Okay, you don't need to make any modifications to them at all. They're expecting 3 parameters. Each one of those methods will use 3 parameters, or if you get rid of the method statement at the top, you're still going to need these 3 parameters to be set to initial values. So they're expecting the array of data type integer, primitive data integer. So they're expecting that there's an array of the name ARR out there, that there's a left variable identified, which is set to the leftmost boundary of the array, and there's a right variable set to either the rightmost boundary of the array or the size. It kind of depends upon the algorithm, and you can run the algorithm and see the results to know whether, oops, that should have been set to the size of the array, or oops, that should have been set to the rightmost boundary. So you can do a little experimentation to see which value your right variable should contain. Okay. So again, I said the bubble sort is my favorite, so I'm going to kind of walk through some different examples with the bubble sort. And again, I copied this right out of the reading guide. Literally highlighted the bubble sort, did a copy paste. Okay, and that was all that I did. So this is the logic code that was inside the method for the 3rd version of the bubble sort. Okay, and let's just come back here to YouTube, and let's look for a bubble sort visualization here. And I'm going to look for a really short one as opposed to a long one. We're just going to run something for a little bit of time here. So yeah, let's just run this guy. We're not going to do all 4 minutes, but okay. So remember, it's going to bubble things up to the left. So see, it's flipping 9 is moving all the way across, and then 9 ends up at the end, and then it stops. It's only going to check inside the middle now. 8 is actually the highest, 6, 7, and 8 are done. It's flipping 5 up, goes across. Now floor is going to be moved to the end. Okay, and now we're sorted. All right. So let's go back over and take a look at how the logic works. So the first thing we do is we have this variable that just keeps track. So it's called did swap here. And the whole purpose of this variable is strictly to say, did I have to change the position of a couple items in the array? Like, did I switch a couple values? You saw how in the video the values were flipping. Did I flip anybody? Because if I didn't flip anybody, then my whole array is sorted and I don't need to do any work. But if I did flip somebody, then there's the potential that something could be out of order and I need to go back through and check one more time. So that's what this first variable did swap. So we're initially going to set it to true because our while loop is only going to execute if it is true. So initially we're setting it to true just to get inside this loop, right? Then we set our last equal to the rightmost position minus 1. So this is keeping track. You remember how that line was drawn in the YouTube video? So here we had that line drawn to show what had been sorted and what hadn't been sorted. That's what the last variable is it's like that line to say, okay, everything above the last was already been sorted, so I only need to worry about last and below. Okay, so we're going to loop as long as our did swap is true, as long as we flipped something or the very first time we're going to go in, and then right away we set our did swap equal to false. All right, I'm beginning my loop. I'm going to assume I did not switch anything. Okay, then we have an array here that starts with our leftmost position, so starts with 0 and goes up to but not including the last position. So everything above the last is already sorted and I don't need to worry about that. Okay, then I'm going to compare what's in position I to what's in position I plus 1. And if it's greater, then I know I need to flip those 2 positions, right? So I would be comparing what's in position 0 to what's in position I plus 1. So if we come back over here, I would be comparing my value. Well, this is already sorted. Let's go back here to where it's not sorted. All right, so here I would be comparing my, let's go a little bit further so we can see the different lines. Okay, there we go. So I would be comparing 3 to 5. If 3 was greater than 5, then I'm going to flip those two, right? But it's not. So then I compare 5 to 1. 5 is greater than 1, so I'm going to put 5 in the 1 position and 1 in the 5 position. So I end up with 3, 1, 5. Okay, then I would compare 5 to 0, and if 5 is greater than 0, I will flip them. Otherwise, I won't. And it is, so 5 would come here, and then 5 to 4, and then 5 to 2, and eventually then I know I'm sorted, so I would move my limit in front of where my 5 is. Okay, so this is really your money work right here. Is what's in position I greater than or equal to what's in position I plus 1? And if it is, I'm going to set my swap to true because I had to flip something, right? So I'm setting it to true. I'm going to put what's in position I into a temporary variable, same data type, integer data type. I'm sticking it in this temporary. Then what I'm going to do is I'm going to take what's in I and I'm going to put it into I plus 1. And I'm going to take what's in I plus 1 and I'm going to assign it the value of temp. So I had to store this off in a temporary variable because as soon as I say I equals what's at I plus 1, I've now lost what value was in I plus 1. So I store it off in a temporary variable. So when I say I equals what's currently in I plus 1, so I move that 3 into I and then I want to put the 5 into I plus 1, I've stored that variable off and I can do that. Okay, and when I get done with this loop, bubbling everything up, I subtract 1 from my last. So my last now shifts over 1. My 5 is now sorted. I don't need to look at it anymore, and I shift over 1 down here. And then I come back up and I start again. I set my swap equal to false. I'm going to assume I don't have to trade any values. And then I work through from left to less than last, not having to look at that value of 5 anymore. And then I compare each of them, and if I find one that is greater, I do a swap. And then I'll subtract from my last, and I keep doing this until either did swap does not change, it continues to be false, in which case everything is sorted, or I don't have to do my inner loop at all because all of my items are unsorted, so II is already less than my last. Okay, I would encourage you to copy your bubble sort or insertion sort or selection sort, whatever it is that you prefer, and to just take it exactly the way the book is, create yourself an integer array and populate it with random values. You can use the same values that are given to you right here if you wanted to in this example, and then just process it and see what you end up getting. Okay? All right. So here I've given you some pictorial versions of the bubble sort, but again, I think it's more fun and more effective to go out to YouTube and watch it sort out there. Okay, so initial state, 6 is greater than 3. We flip those two. We put 6 into position 1, 3 into position 0. Then we compare 6 to 8. That's not. 6 is not greater than 8. We compare 8 to 2. 8 is greater than 2, so we put 8 into position 3, 2 into position 8. Okay, and we compare 8 to 4. 8 is greater than 4. We put 8 into position 4, 4 into position 3. Then we compare 8 and 7. 8 is greater than 7. We put 8 into position 5, 7 into position 4. So now 8 is in position 5. We subtract 1 from our last, so we'll no longer check this one. We only check these areas right here, and we keep doing that until eventually we are in correct sorted order. Okay, now as I stated, this is your money right here. This is the key area. I mean, all this other part of the algorithm is indeed important, but this is the area right here where you're swapping the values. Okay. So this is your key value area. We're comparing and we're swapping. So if I needed to modify this bubble sort to work with something else, maybe to work with double data or to work with string data, this is where I'm going to make all of my modification right here. I don't need to change anything up here, only this section highlighted in green. Okay, So for an example, if I wanted this to work with double data as opposed to integer data, so I still have an array, it's just now defined with data type double, not data type integer. I don't need to change my comparison, that's still going to work. I don't need to change my did swap, but I need to change this right here. My temp variable can no longer be defined as integer because I'm going to be storing off into it double data. So I would just change this one line, double temp equals array sub I. So I'm really just changing the data type from integer to double, and all the rest of this stuff holds true. So in this previous example, to make this work with double data, excuse me for a moment, I would have defined an array of data type double, right, and populated it with double values. But the only thing I need to change in my sort algorithm is this one data type right here, from integer to double, and this will now work with double data. And I would encourage you, let's say you've already tried out the bubble sort with an integer array, flip it to a double array now and make that one change and see that it will indeed work. Okay. If I wanted it to work with string data, I'm going to have to actually make two changes. So I do need to change the data type of my temporary variable that I'm temporarily storing things off from integer to string data, but my comparison also needs to change. So I can't just compare string data. Is this data greater than the other? I'm going to want to call the compare to method of string data. So I would actually do array sub I dot compare to, and as the parameter I'm going to pass array I plus 1. Okay. I'm going to check to see if this is greater than 0. The compare to string function will compare two string values to each other. If they are equal, it will return a 0 value. If it is less than 0, then that means that array 1 is greater than array I plus 1. So array I is greater than is lexicographically, meaning alphabetically and by case, is greater than array I plus 1. If it's greater than 0, then that would mean that this array sub I is actually less than I sub 1. So I just need to make those two changes to the algorithm. The whole rest of the algorithm is correct. I just need to change these two things, my comparison and then the data type of my temporary variable. And that's it. So you can see you could take this sorting algorithm, the bubble sort algorithm, exactly from the book, from the reading guide, copy and paste, right? And then modify it to work with whatever kind of data that you're working with. Okay. Now, we have been using this with array data, but maybe you want to use this with an array list data as opposed to an array. Okay, so to do that with an array list, what you have to remember is you have to use methods. So we can't just say if array sub 1 or sub I is less than array I plus 1, because we can't do that. We have to call the get methods. So here I have shown you value 1 equals array, it should be parentheses, the get method, right? And array I plus 1 with the get method, and then changing this to a data type object here as opposed to just integer or primitive data types. So here's how that would look, converting it to work with an array list. So instead of array sub I and array sub I plus 1, we had array dot get I is greater than array dot get I plus 1. Okay, so here we have direct access because we're using an array. Here we have to call the get method, and the same thing here, we have to call the get method. So we'll replace those two values. We're going to change our data type from int primitive data to integer wrapper class data, and we can't just set it directly equal to the value. We have to call the get method, so array.get sub I, right? Then we're going to change. Now this time we're going to have to use the set method, and we want to set our position I equal to what's in I plus 1. So we have to retrieve what's in I plus 1, array.get I plus 1, and we're changing position I. So we're doing an array.set I comma array.get I plus 1. And then here we're going to set what's at I plus 1 with what's in our temporary variable temp. Okay, so a little bit more work when you're converting, when you're not using an array, but you're using an array list. But still, the majority of the algorithm is unchanged. We're only changing inside of that if statement, right? So we just change the way we're retrieving data and then the way we're setting data. Okay. So that was the sorting algorithms. As I said, I really encourage you, one, go out to YouTube, make sure you understand how each of the sorting algorithms work by running one of those visualizations, okay? Then copy an algorithm into BlueJ. You can easily just create a little main method in BlueJ, so like a little driver or demo program in BlueJ. Define yourself an array at the top and pre-populate it with some values. And I would create, like an array integer, an array double, an array string, and then, write the sorting algorithm to work with each one, and then print out the values of your array to ensure that they've been correctly sorted. Just really familiar yourself with the arrays. You'll definitely be asked questions about the arrays on the final exams. You want to make sure that you understand how each of the different sorting algorithm functions. Okay. All right, last topic here, just a couple of slides, is multi-dimensional arrays. And so think of this as like your Excel spreadsheet where you've got the alphabet going across the top. So your rows are going across the top and you've got the numbers going down the side, and those are your columns. And so you reference like cell A1, A2. That is essentially a two-dimensional array. And so when you're setting up a multi-dimensional array, you define the number of rows, and then you define the number of columns, and then you'll define it. So whatever your data type is, and you're going to have these square brackets for each dimension. So if it's a two-dimensional array, two sets of square brackets. So one-dimensional array, one set of square brackets. Two-dimensional arrays, two sets of square brackets. Three-dimensional array, three sets of square brackets, and so on. Okay. Array name equals new, whatever your data type is, integer, string, double, whatever you're defining it as, and then your square brackets here with your size parameters. So we're doing a two-dimensional array, so we're giving it rows and columns. If we had a three-dimensional array, we'd have a third set here and a third set here, and so on. So I would say, you might be asking, oh my gosh, how often does this happen? I would say you get into two-dimensional arrays on a fairly regular basis. I mean, not every day, but I would say I probably encounter maybe once a week or something with a two-dimensional array. I've never really gone much beyond a two-dimensional array in just my day-to-day experiences. If you're getting beyond into a three-dimensional or four-dimensional, you're probably getting into some graphical type displays. So I have done three-dimensional arrays back when I was studying graphical displays, and so I was like creating a vase with light sources and all that sort of thing. So I got into three-dimensional arrays in that particular situation. But in a day-to-day business-oriented type environment, two-dimensional is probably the largest that you will encounter. Okay, so when you want to traverse a multi-dimensional array, in this case it's a two-dimensional array, so we've defined an array of 5 rows and 6 columns. It's data type integer. We've got our 2 square brackets for the 2 dimensions. The name is array name, equals new integer, and we've given our rows and columns. Then we'll have an outer loop, so I equals 0, I is less than rows, I plus plus, and an inner loop, j equals 0, j is less than columns, j plus plus, and then we'll just traverse through system.println, array name, I sub j. So if this was a three-dimensional array, I would have 3 loops. Okay, so I would have 3 nested loops, 4 dimensionals, 4 nested loops, and so on. So for however many dimensions you have is however many square sets of square brackets you're going to have here, and how many loops you're going to have to be able to traverse that particular array. And again, I would encourage you to play around with this. Like create a two-dimensional array, populate it with some values, and then print it out. Or maybe you do a scanner class and you ask for a value in and you populate the array by just doing array name sub I sub j equals whatever you got off of the console, and then turn back around and print it out and see what you get. Play around with it, experiment, give it a try. And that is it with regards to the week 9 lessons. So again, for this, we covered wrapper classes, so taking primitive data and converting them to object data so they can be used in constructs such as array lists and others that require that. We talked about auto boxing and auto unboxing, which just means we don't have to call the constructor to create an object, or we don't have to call methods to retrieve that primitive, to convert from an object to primitive data, or converting from primitive to an object. We don't have to call the methods or the constructors. That Java provides a shortcut for that. We also talked about the sorting algorithms. So we talked about selection, insertion, and bubble. And I showed you to go out to YouTube so you can see how those work, and then how you can take the algorithms that you were provided in the reading guide and use those at verbatim, right, in your code. Okay. So certainly if you have any questions, please do not hesitate to email me or to post things out to Piazza. And that concludes our week 9 recording.